Hello students, today we will discuss the chapter moving charges and magnetism. First, let me take up the first concept, the force acting on a charged particle in an uniform magnetic field. The force acting on the charged particle in an uniform magnetic field is given by the formula F equals to QVB sin theta, where Q is the charge of the particle, V is the velocity of the particle, B is the magnetic field, theta is the angle between the velocity of the charged particle and the magnetic field. That is, F equals Q V B sin theta. Now, Q is the charge, V is the velocity, B is the uniform magnetic field, theta is the angle between the velocity of the charged particle with the magnetic field. If B is the magnetic field which is acting in this direction, if the charged particle is moving in this direction which makes an angle theta with the magnetic field, then the force experienced by the charged particle is given by QVB sin theta. When the charged particle is not at all moving in an uniform magnetic field, suppose if it is at rest, then the velocity of the particle is 0, therefore the force acting on the charged particle is 0. So, if the particle is at rest, then the velocity of the particle is 0, this implies the force acting on the particle is 0. Then, if the charged particle is moving in the direction of the magnetic field, that is theta equals to 0. If theta equals to 0, then also the force is going to be 0 because sin 0 is 0, then the force experienced is a 0 force when the charged particle is moving in the direction of the uniform magnetic field. Then, when the force acting on the particle is maximum, then if the charged particle moves perpendicular to the magnetic field, then the force is going to be a maximum, that is when theta is 90 degree, the force acting on the particle is maximum, that is equal to QVB. So, this is the maximum force acting on the charged particle when it is moving in an uniform magnetic field. Remember students, when the force acting on the particle is maximum, if the charged particle moves perpendicular to the magnetic field. And also when the charged particle moves in an uniform magnetic field, it moves in a circular path. Now, let us consider a uniform magnetic field which is acting into the plane. The force acted upon by the charged particle when it is projected perpendicular to magnetic field. Let us say there is a charged particle here, it is projected perpendicular to the magnetic field. Then this charged particle will experience a maximum force which is equal to QVB. Because of that force, this charged particle start moving in circular path of radius, let us say r. When this charged particle moves in circular path, it will experience a centripetal force. That centripetal force should balance with this magnetic force. So, I can equate this QVB equals to mv squared by r. On cancelling with V term, can you get the value for expression for R? That is R equals to mv divided by QB. So, remember, when the charged particle is moving in a circular path, the radius described by that particle in the uniform magnetic field is given by the formula R equals to m into V divided by Q into B, where m into V is also nothing but the momentum. So, this momentum can be taken or replaced by root of 2m into kinetic energy divided by Q into B, or root of kinetic energy can be replaced by charge into potential divided by Q into B. So, when the charged particle moves in an uniform magnetic field, remember the formula for the radius R equals to mv divided by qb, or it can be taken as root of 2m ek divided by qb, where ek is the kinetic energy, and in terms of potential R is equal to root of 2m qv divided by q into b. Let us take up the next concept, students, that is the force acted upon by a straight conductor when it is placed in a magnetic field. Let us say the uniform magnetic field is acted here in this direction. In this uniform magnetic field, if I place a straight conductor carrying current I and length L, then the force experienced by this conductor is given by the formula F is equal to BIL sin theta, where B is the magnetic field, I is the current, L is the length of the conductor, theta is the angle made by the straight conductor with the magnetic field. Then here also you can find when the force is going to be maximum and minimum. The force is going to be maximum when theta is 90 degree, that is, if the conductor is placed perpendicular to the magnetic field, the force is going to be maximum, that is equal to BIL. If the conductor is placed parallel to the magnetic field, that is theta equals to 0 degree, then the force experienced will be 0. Students, let us take up the next concept, that is BIOT-SAVARTS law, which is nothing but the Laplace law. This BIOT-SAVARTS law or Laplace law gives the magnetic field at a point due to a small element carrying current. Suppose if I considered a straight conductor or any conductor, in that conductor if I considered a small portion of length dl carrying the current I, then what is the magnetic field produced by this small element at P? That can be given by the BIOT-SAVARTS law. According to this BIOT-SAVARTS law, the magnetic field acting at the point P, that is let us say dB, is equal to mu naught by 4 pi into I dl sin theta divided by r square, where I is the current flowing in the conductor, dl is the length of the element, r is the distance from the midpoint of this element to the point P, and theta is the angle between that element and the line joining from the midpoint of the element to the point P. So, BIOT-SAVARTS law is nothing but the magnetic field at a point produced by the small element carrying current, which is given by mu naught by 4 pi ideal sin theta divided by r square. You can also represent this in vector form. In vector form, this magnetic field is given by mu naught by 4 pi into I into dl vector cross r vector divided by r cube. This is what we call the BIOT-SAVARTS law. And also please remember, students, this BIOT-SAVARTS law is applicable to find the magnetic field only for the small element carrying the current I.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.